Hello friends, welcome back to MeshMind. In this video, we will learn how to interface a switch with the 8051 microcontroller and use it to control an LED. We will start with the basic interfacing, then understand the different types of switch interfacing, and finally write a program to turn an LED on or off with a switch. So first, understanding switch interfacing with 8051. A switch is a simple input device that can connect or disconnect a circuit. When interfacing a switch with the 8051, we connect it to one of the microcontroller's input pin. When the switch is pressed, it changes the logic level at that pin, which the microcontroller can read as high or low. So there are two common ways to interface a switch with a microcontroller. First is active high logic interfacing. In active high logic, the microcontroller pin reads high when switch is pressed and low when switch is released. How it works? When switch released, pull-up resistor pulls pin to logic low, program reads 0, LED will off. When switch pressed, pin is directly connected to plus VCC, logic is high, program reads 1 and LED will on. Then hardware wiring. One side of switch is connected to plus VCC and other side is connected to 8051 input output pin. An external resistor is connected between 8051 input output pin and ground. Now let's write the program. Hash include res51.h. res51.h is a header file, gives access to port and bit definitions. Then declare pins. S-bit switch is equal to P1 cap 0, switch connected to pin P1.0. Then S-bit LED is equal to P1 cap 1, LED is connected to pin P1.1. Then start the main function, void main. Then make P1.0 high impedance so it can read input. Switch is equal to 1. Configure P1.0 as input. Then keep LED off at start. LED is equal to 0. Initially LED off. Then use infinite loop to check condition forever while 1. Here while 1 is an infinite loop. Then check if the switch is pressed. For that we use EPL conditional statement. If switch is equal to 1. Here is equal to is comparison operator. If the switch is pressed, then on the LED or write the high logic on LED pin. LED is equal to 1. Here LED is on. Then else. In the else statement of the LED, write low logic on LED pin. LED is equal to 0. Then close the else statement, close while loop and close main function. Then debug and test the program. First build the program. Ensure the output window shows 0 errors and 0 warnings. This confirms your code has no syntax issue and is ready for simulation. Then start the debug session. Click on debug. Then click on start/debug session. Then debug session window will appear. Then access the port view. Click on peripherals. Then click IO ports and select port 1. You will now see all 8 pins of port 1 displayed as checkboxes or toggles. In our program, switch is connected to P1.0 and LED is connected to P1.1. Then click on run button. Then click on the P1.0 toggle to simulate pressing the switch. When P1.0 is released, then you can see LED pin P1.1 turns off. When P1.0 is pressed, then you can see LED pin P1.1 turns on. Once the simulation works correctly, stop the debug session. Now let's see active low logic interfacing. In active low logic interfacing, the microcontroller pin reads low when the switch is pressed and high when switch is released. How it works? When switch released, pin is connected to internal pull-up, stay at logic high. Program reads 1, LED will off. When switch is pressed, pin is connected directly to ground, logic is low, program reads 0, LED will on. Then hardware wiring. One side of switch is connected to ground and other side of switch is connected to 8051 input output pin and resistor is connected between VCC and 8051 input output pin. Now let's see the program for active low logic interfacing. So here only change in the if statement. Here change if switch is equal to 0, then LED will on, otherwise LED will off. Then again build the program. Ensure the output window shows 0 errors and 0 warnings. Then click on debug, then click on start/stop debug session. Then click on peripherals, then click IO ports and select port 1. Then click on run button and here you can see the output. In the next video, we will see how to interface relay with 8051 microcontroller and its programming. If you found this video useful, don't forget to like, share and subscribe to MeshMind for more embedded system tutorials. So see you in next one. Thanks for watching.